Okay, now we're going to fetch some data using the CCS 811 sensor, just some air sensor data, so CO2 and volatile organic compounds, and then I'm going to put this data over the LoRaWAN network to TTN servers. From TTN I'm going to create an integration with the Ubidot, and from that I'm going in that cloud I'll build a dashboard, create some automation triggers, and also share that dashboard, and we'll see well, all the things we can do. Just to mention, this is just one of many. I've chosen this one as the first one to start with, just because it's pretty easy and powerful and also free. But I would guess we can find at least 10, 15 just by looking around. I'll put a list on our course notes. So let's start with my connection and what I've been doing. So I've just connected the CCS 811 sensors here to my PyCom device, and it's connected with a LoRa antenna. I'm running on the European LoRa band, and I'm in range of my gateway, so it's pretty close actually. It's just 50 centimeters from the device, but it will work that way. So let's just skip through directly to the code, and you can find this code on our GitHub page. So please have a look at it. And I've structured this project a little bit different since the previous projects, because I want you to give an insight on if you have too many things, you need to structure it in a good way. You can of course just write everything in the main.py file, just from up to bottom, and put all your code in one file. But if you work with a lot of libraries, if you do a lot of things, and if you try a lot of different projects and sensors, you might want to structure it in a better way. So I'm not saying that this is the way to do it. You might find a better way. I'm not saying this is the absolute best way, just to make sure. But this is just one way of structuring your code for a very small project like this. And I'm just going to show you, if you look at this main.py file, this file, it's what you see here is all in this file. And I'm first importing a library which I've created called CCS read. We'll have a look at that. And then I'm importing LoRa. I'm importing struct, which is something that we will be using when we send the data. I'm going to talk about how we package our bytes to before we send it away. And then just the time library for timing. And then you can see that I have one function I call here connect LoRa. So as you see here, I imported something called LoRa here, and then I have LoRa.connect LoRa. Okay, so let's start there and just see what happens. When I import LoRa, it actually is this file which I'm importing. And you might be familiar with this file. If you have worked with the TTN examples before, this is pretty straightforward. It's more or less the same code as is in the basic TTN examples you can find at the PyCom website, and also in the other examples which we have been talking before. So we're here, just importing the LoRa from the network, socket, time, Ubidots, ASCII keys, and PyCom. I just mentioned this. I'm importing the keys. We'll show you just a couple of lines lower why I'm doing this. And you can see here I'm using the PyCom heartbeat for showing if I'm connected or not. I've talked about this earlier, and it's a pretty neat way of using this LED light on your PyCom device to show what's happening. Initializing LoRa here. I'm printing the ID of the device. This is really not needed. It's only when you set it up for the first time. But anyway, that's what happens. And then you can see here, create the OTA authentication parameters. If you remember from the first basic example, I manually put in the keys here. A better way to do it is to have a standard way, just have the same file, and if you reuse this file, you only need to import the keys from a different file. So if you look here, I'm importing keys, and what I'm actually doing then is that I'm importing this file, which contains two variables, the app and the identifier and the app key. So these are the same keys as we saw in the last video. I've actually not changed the device, so this is already registered at the TTN service. But instead of having this code directly in my these keys directly in my code, I create a key file, and in this way I can put this file in a git ignore. Also, it's pretty easy for me. If I just want to keep the exact same code, I can, well, just change this key file. But especially when you share your code, now you can easily just put this in your git ignore. You can share all the other code and just you don't have to give away your keys. So this, I would say, is a pretty good practice to do it. And what you do when you import it is that you just import these two variables by writing this way. Otherwise it's the same. And then instead of just having a script straight down, so when I import this file, LoRa file, it's automatically executed within a subroutine, and this is a function called connect LoRa. So this function, it doesn't have an output, it just runs when I call it, but this is the join function. So I've put the join sequence in a function, and if you look, it's the same basic code, but I'm playing a little bit with the RGB LEDs. So while it's searching for a join, it's blinking in a bluish color, and when it has joined, it will blink a couple of times green. That's it. And then I'm just creating a socket, and will run with data rate 5. If you need longer range, you should change this to 0, and it will be longer range. So if you're in like an area where you don't have a good range, change this to 0, and you will get better range. Okay, so let's go back. Now you can see that, okay, I'm first running my main.py, I'm connecting to LoRa, and then I'm importing the socket from LoRa, importing socket. That's just because I'm lazy, I don't want to write it out. And then I'm defining yet another function. This is one way of doing it. I'm not saying it is the best way. Actually, it might look a bit odd, because I have a function here which I have in a loop later down. I could have written, well, everything in a loop and not in a function. But when you're playing around with your code, You might want to put that in a function, because now it's pretty easy for me to just send a value from the REPL interface. So I just have to call the function send value, and well, I embed everything I want to do to send the value from my sensor in that function. And that's much easier when you work with your code in your REPL interface. Let's look at CCS read. And this is from my previous example when I just showed the CCS 811 sensor. So this is the exact same code. The only thing here which I've changed for this example is that I've yet made yet another function call within this this file, which is called value. So when I call this function, the value function, I am just fetching the CO2 and VOC values. And this is just to a sanity check. So if you don't get the value, sometimes you don't get the value if you're too fast. That's why I have a sleep function here for 4 seconds. If you're too fast, it will give an error. And also, I know from the specifications of this sensor that, well, it doesn't give anything below 400 ppm of the CO2, so I use that as a sanity check. You could probably do it better in another way and better. But this means that I have a pretty compact main.py file. So my main code is very compact in this case. Just talk about what I'm doing here is that I'm using 2 bytes for the CO2 and the volatile organic compounds. I'm sending actually 2 bytes for the CO2, and I'm sending 2 bytes for the VOC. And I talked about payload functions earlier, and you need to be aware that you send as little as possible. And by using 2 bytes, you have a lot of resolution. You don't, well, in this case, by reading the specifications of this device, this gives a CO2 value between 400 ppm up to 8,892 ppm. So that's the range. If I'm using 1 byte, I could have a resolution of, that's a resolution of 256. That's the range. So in that case, I would have about 6,700. That's the range which I have a value in the CO2 range. If I divide that by, let's see, if I take 192 minus 400, so that's the range. And if I divide this by 256, I could get the resolution of about 30 ppm CO2 if I use 1 byte. So I'm just saying, but well, I might want to have every ppm level. I'm not sure about how accurate this sensor is, but I mean, I'm not, probably I don't need to be that, save that much data. 2 bytes might be enough. And how much can I get out of 2 bytes? Yeah, that's 2 raised to the power of 16, so 65,536. That's how much, that's the range you can get with only using 2 bytes. And that's good enough. I'm not going to use any negative values. We don't have a negative CO2 value. That's also a good thing to know. So I really don't have to, well, the same thing with volatile organic compounds. There is no negative values. So I don't have to care about using a signed payload. It could be an unsigned payload. That means that I'm sending something between 0 and 65,536. That's it. So it's pretty easy. And in this way, I'm structuring this just to make sure that I'm sending an integer. I'll just put an int function outside this. So I'm reading the value, I'm printing it just so I can see what happens down here. Then I'm just creating a package, and this will create a package of 4 bytes, which I'm then sending away when I call this function. And this just sends it every 30 seconds. So let's see how this works. Let's put up the sensor as well, and you might see the LED. So I've actually just exited this loop, and if I go back to, I have the Things Network console here. We can look at the data from my application. I'll upload the project to the device. And hopefully it will work. So not yet joined, and you can see that there is a bluish light here which is blinking, and now it's blinking green. Great. This means I've joined, and you see that I'm now sending data 403 in CU2, and the volatile organic compounds are 0, and that's good. And we can also see the payload. The payload here it's 4 bytes, so exactly as I said. And then you can see the fields here, CU2 and VOC. And well, I've already prepared. This won't happen automatically. You need to create your decoder. And I've already created my decoder. And this, you can see the decoder. You can find it on GitHub as well. It's in decoder TTN JavaScript. And this decoder will obviously only work for this exact application. So, I mean, if it's not a decoder that works for everything. So when you're sending your data, you have to define what resolution do I need for the data, how much, well, how often do I need to send data, and then you write in the decoder of in TTN. That's where the bytes come in, and you actually transform these bytes to something that you can have readable by something else. And in this case, we can see that, yeah, it gives an object. It will come out as a JSON object here with CU2 411 and VOC 1. And I'll just try to see if something happens when I have this sensor very close to my mouth. It will probably be much higher. So let's see what happens. I'll brief on it, and 30 seconds, every 30 seconds it will update. I could have done this manually, but this is more exciting. And obviously I've already tested this, but the range goes up to about 8,000 ppms. Oh yeah, let's see. I got a result here, 1,527 and VOC 190. Well, probably, yeah, if this would have happened just in an indoor atmosphere without me briefing on it, that would be an indication of a pretty poor air quality. And so we can see that this seems to be working now. And obviously you can send whatever sensor data you want. It's just a matter of setting up what you want to be sending out. But the thing here is that now my data only ends up at the TTN servers, and not only, but well, you don't really have any use of having your data only at this place. So we need to take the data and put it somewhere else. Either you can do this and take it down to a local instance on your computer. We're going to talk about that in a later session. But in this session, I'm going to show you the Ubidot integration. And there are a lot of ready-to-use integrations. So here you can see that I'm in my sensor. In my application, Test Sensor Vancouver, I go to integrations. I create an integration, and you can see that, okay, I have a lot of integrations to choose from. And you can use, for instance, IFTTT, which is if, then, that, to create all kinds of triggers. You have the HTTP integration. You can create webhooks. There is open sensors, my devices, tag IO, ThingSpeak, Ubidots, everything, all things talk, and well, there's a data storage and Colos. I must be honest, I haven't tried them all. I'm happy to hear your experiences, but we'll start with something that I know works pretty well and is free. And so, Ubidots. Let's just create. You have to create your integration and create the process ID. I'll just write Ubidots. I'll use the default key. And there are great guides on Ubidots. Integrate your TTN data with Ubidots, simple setup. So if you have created an account on Ubidots, which you can do for free, remember to go into ubidots.com/stem. So they have a special account for science, technology, engineering, and math. So it's an education account. And they give forever free devices, and there is well, you can create triggers and dashboards, etc. There are a lot of other free services also, but I must mention this is obviously just for development. If you want to scale your idea to something else, well, you have to pay, and obviously that's how most of these services work. They give you, well, some things for free. So when you're developing something, well, if you like the service, they might make money on it in the long run. If you really like the service, we might go and pay. But create an account here and you're good to go. I've already done that, so I can just go to my dashboard. It should be a clear dashboard now. I've cleared it out. And just first look at, okay, I'm going to integrate with TTN. So what I'm doing when I'm integrating this way is that the backend between TTN and Ubidots are connected together. So it's a pretty neat way of doing things. And if I read this guide, the only thing that I need is an access token from the Ubidot system. And you can find that under APA credentials, and I'll just press copy. Now the token is copied to my memory. This token should obviously not be shared. And that is how easy this is. Now we have an integration with Ubidots. It's up and running. And we are already pushing data into TTN. So if everything is working, I hope we'll be able to automatically see something showing up here. I'll go to my devices and voila, a few seconds ago, you see something popped up here. And this is just my device ID. I can rename it, obviously. Press this one. I have two variables here, CU2 and VOC. That's great. And this is now being pushed from my device over the LoRa network up to the TTN server, and from the TTN server to Ubidots servers. So it's a long way for the data. And as I'm using the European servers, it's most likely traveling all around the world, at least once, I guess. But it seems to be working. So I can play around. There's a lot of things. I can press this data, and it's, as I speak, it's sending every 30 seconds now. So it will continue to just fill in. I can go in. I can export my data and such. But just let's go directly to a dashboard, because that's a pretty neat way of showing your data, and I think that's what you have in mind. And well, many of you have projects which are you need to create a dashboard. So let's create a dashboard. Add dashboard, and I'll just write my air quality dashboard. That's good. And the last 24 hours, that's okay. There is a lot of settings here. You can, well, do a lot of settings. Screen size, floating widgets, etc, etc. I'll just let it be. And now I have my dashboard. And now I'm going to create a new widget. And this could be a lot of things. So you can put maps here, you could put pie charts, well, line charts, etc. But in this way, I want a line chart. And I want this to display CO2. And well, just add a variable, and you can see here I have my device here. If I would have 10 devices, well, in this case you can only add 3 devices as it's limited to that in the free service, but I could have 10 sensors on my device here. Then they would show up, and it could be from 3 different devices with 10 sensors each, and I would have 30 to choose from. You get the point. But I'll press CO2 here, and let's just continue going. I'll just leave everything as standard as it is. Oh, here's carbon dioxide, and in this dashboard there is a lot of things I can play around with just by, well, as standard. I don't really, I get a pretty neat looking dashboard just right away. Let's add the VOC as well in just beside this one. I can move them around. I could add metric here. Maybe I want to show this data in another way. I could just take the last hour. Yeah. Let's see the last value. Yeah, you can, and I can write and do whatever I like here. And if, well, let's say that I have a GPS tracker, obviously I could put a map here and push my GPS data and have a temperature if I would, well, you get a point. If I want to do something more, this dashboard is now only for my eyes. I can actually share this dashboard. So if I press share, create a link, and this is should be a public dashboard. So which I should be able to share with someone. You can access this one, and also I can press this in full screen mode, and if I want this to be shown at some screen somewhere, someplace. I could also pretty easily in this service, I would say, create triggers and just create an event. Select a variable. Let's say that I want CO2. Value is greater than, let's say, 415 ppm. A new action. Well, let's send an SMS. It's an old way of doing it. And that's my phone number, and then just go. So now we have a SMS if we have a ppm over 415 ppm, if this works. Let's see. It's very exciting. I'll probably brief a little bit. Now you can see here I got I have to show you. This is so exciting. Here you can see probably not very, but yeah, I got, hey there, CO2 was 438 at 2020, well, 1857. Oh, so it worked. So that was my first try on showing out the Ubidots dashboard and integration with the TTN servers. You can push data to Ubidots directly over Wi-Fi. You don't have to go and pass via the TTN servers. There are other ways also. You can create webhooks. So instead of using the integration which I showed you now, you can create a webhook which pushes the data into the Ubidots. So there's a lot of ways you can do it. So as long as you have your data in TTN, you can get it from TTN to wherever in a pretty easy way. So yeah, thank you for your attention and hope you have fun.